So today I'm gonna do this pandas, this Kaggle pandas course. I was trying to do the rock paper scissors for Recode Camp, and then I was having some trouble trying to figure out how to do it. And while I was doing that, a book that I bought arrived. Here's the book, I think. Uh, and then I read the first chapter, and at the end of the first chapter, the author tells you to do some projects on the site to try to incorporate the stuff that he teaches. So then I've heard about the site before, but I didn't look into it. Look, I didn't look much into it, and then I started looking on the site when I started doing this project here. House prices advanced, and I found out that they have courses for machine learning stuff. So I think it's a good way to practice things and hopefully manage to finish the challenge. I think I'm kind of halfway through there, but yeah, just I'm not sure if there's a lot more to go because it's my first project. So and this micro course, you will learn about all about pandas, the most popular Python library for data analysis. Along the way, you complete several hands-on exercises with real-world data. We recommend that you work on the exercises while reading the corresponding tutorials. To start the first exercise, please click here. I already did this thing here. So I think what they want me to do is read this first and then try to do the exercises. There are two core objects in pandas: the data frame and the series. Data frame. A data frame is a table. It contains an array of individual entries, each of which has a certain value. Each entry corresponds to a row, a record, and a column. For example, consider the following simple data frame. So a data frame is a table, which is kind of like a Excel spreadsheet. The example, the zero no entry has a value of 131. So it's the location here. The zero yes entry has a value of 50 and so on. Data frame entries are not limited to integers. For instance, here's a data frame whose values are strings. Yeah. You're using PD data frame constructor to generate these data frame objects. The syntax for declaring a new one is a dictionary whose keys are the columns names Bob and Sue in this example, whose values are a list of entries. This is this is the standard way of constructing a new data frame, and the one you are most likely to encounter. The dictionary list constructor assigns values to the columns labels, but just uses an ascending count from 0 for the row labels. Sometimes this is okay, but oftentimes you want to assign these labels ourselves. List of row labels used in a data frame is known as an index. You can assign values to it by using an index parameter in our constructor. So if understood, the index is the value of each row on the first column. A series, by contrast, is a sequence of data values. If a data frame is a table, a series is a list. And in fact, you can create one with nothing more than a list. So if I understand, the series is like the rows on the table. Maybe not because series showing. Oh no, yeah. Series showing as a column, but I think it's the row from the stuff I've been trying to do so far. A series is, in essence, a single column of a data frame. Also, it is a column. So you can assign column values to the series the same way as before using an index parameter. However, a series does not have a column name. It only has one overall name. The series and the data frame are intimately related. It's helpful to think of a data frame as actually being just a bunch of series glued together. We'll see more of this in the next section of this tutorial. So one thing I'm still having trouble with understanding, and I had problems trying to build stuff on the project, is the difference between a series and an array in the way that the computer interprets. I know they're different, but I'm not exactly sure how the computer sees it differently. Reading data files. Being able to create a data frame or series by hand is handy, but most of the time we won't actually be creating our own data by hand. Instead, we'll be working with data that already exists. Data can be stored in a number of different forms and formats. By far, the most basic of this is the humble CSV file. When you open a CSV file, you got something that looks like this. So CSV stands for comma separated value, I think. So a CSV file is a table of values separated by commas. Hence the name comma separated values or CSV. Let's now set aside our toy data sets and see what a real data set looks like when we read it into a data frame. We use the pd.readCSV function to read the data to a data frame. This goes does thusly. I don't know what this word means. So I'm thinking about sharing the project if I finish. I'm not sure if I'm gonna finish or not. The advanced house techniques stuff. Because from what I did so far is more about cleaning the data, and although that I understand that this is a very important part of machine learning, it's probably the main part of machine learning. But I'm more curious about the way that the algorithms work or the stuff that I want to do first out of curiosity, and then so I want to follow my curiosity more than trying to follow a how can I say rigid path. Maybe it's the right way to put it, because I think I'm gonna learn more if I do stuff that I'm curious about, because it's gonna motivate me more. And the way that I what what I did so far on that project was just clean the data, then separate the numerical values, clean the numerical values, and apparently that's what you have to do on our project, and it makes sense. And the first to find the stuff in the data, you clean it, you prepare it, then you run the algorithm. But I didn't catch the part of the machine learning stuff. Yeah, so I'm not really sure if I'm gonna finish the project. But even if I don't finish, I might just show what I did and why I did it, because I couldn't find a lot of videos there out there explaining. Uh, there are some videos that I saw, but they lacked some things that I think, uh, if I show, might be useful for someone. Dump truck on overpass dump does in this way. Yeah, kind of got the gist of what this means. You can use the shape attribute to check how large the resulting data frame is. So shape tells the size of the data frame. Our new data frame has 130,000 records split across 14 different columns. That's almost 2 million entries. In examining the contents of the resultant data frame using the head command, which grabs the first 5 rows. Okay, so red grabs the first 5 rows. The PD reads CSV functions while in doubt. I don't know what this word means, but over 30 optional parameters you can specify. For example, you can see in this dataset that the CSV file has a built-in index which pandas did not pick up on automatically. To make pandas use that column of for the index instead of creating a new one from scratch, we can specify an index call. So there's over 30 optional parameters you can use here. Also, Seer was unnamed. Then, oh, I got it. So there's true IDs here, and because pandas didn't pick up, CSV file has a built-in index. So when your CSV has a built-in index, like this example, which is this here, to make pandas use that column for the index instead of creating a new one, you can specify an index call. So index call is gonna determine which column of your data frame is gonna become the index, the new index. I'm assuming if you put a different number here, it's gonna take the columns that are in the sequence of the series. So I'm pretty sure that, yeah. So it is this right here. The first step in most data analytics projects is reading the data file. This exercise will create you create series data frame objects both by hand and by reading the data files. On the code cell below, to load libraries you need, including code to check your answers. In the cell below, create a data frame fruits that looks like this. So I'm not sure if they want me to use PD. I think it's data frame, the one that makes more sense. Oh, but oh, that should be like this. And then I'm not sure if it's on strings or not. I think that's it. How can I run this? So here, just click this sound. Hmm. Or maybe I have to write fruits here as well. And now it shows up. So I guess it's because it was marked down here on top. So invalid syntax. Maybe if I take this off, it works. Mm. Let's check the thing here. Forgot how they did it. Oh, it should be inside of an array, and it has should be inside of now an object. No, I don't think it actually needs to be inside of an array since it's one value only. But maybe it's best practice to do it like that. I'm gonna check like this first. Yeah. So maybe it is required. Array or list or whatever it's called. So it's let me take this off. Yeah, there we go. So it's an object inside of, and then inside of each key, which is a column, we have the list of the thing. Create a data frame footer sales that matches the diagram below. So it's pretty much gonna be the same as this one, but with more values instead. Oh, now actually there is an index here. So maybe they want me to put the index call thing. Hmm. Actually, I don't know how to do this. Because this will create the zero here, not the thing. Imagine it's something with the index call stuff, but yeah, let me look at the oh index equals then no array. So I guess there is the index row as well. No, that doesn't make sense. So why would you need to specify index column? Maybe it has to be a string here. Probably has to be a string. But I'm gonna do it without just to see to make sure. Oops. How do I delete that? Yeah, that should be in the string. Nice. Create a variable ingredients with a series that looks like. So the first value has to be an array, but there's nothing in the top there, like this one. Yeah, but that's the thing though. I think this name stuff is gonna go in the index because it's together here by a comma. So I'm gonna try like that and see if it's correct. Yeah. So it's an array with all the values. The last value is gonna be an object. Name, dinner, and the type. Pretty sure it's a string, but not sure. Then object, I think, doesn't need to be on the string. I got the habit of pressing Ctrl S every time I write code. Hashable type list. So that should be the index, the problem. Oh, it's a series, not a data frame. Hmm. I forgot. I'm gonna have to look at the thing. I think it's PD series and then an array or list. PD series. Yeah, so but I'm not sure now if I have the index there. Yeah, I think it's just the same thing, but I just changed the series here. So here, I guess. If a value is 4 does not match index. So data index, the type name, copy fast path. So maybe this has to be a list, not an object. but I'm not sure. Now it's giving me this stuff. Yeah. So maybe D type comes with the thing. I don't need to write it, but it still is a problem because of this one here. Series is in essence a single column of a data frame, so you can assign column values to the series the same way as before, using using an parameter. However, a series does not have a column name. It only has one overall name. Oh, so it's just name. Then that's what I'm doing wrong. Name is a method, and I need to delete this. Oh, I forgot the end of the string here. Nice. So the type comes automatically, and it's an object because there are strings here. Let me see what comes up if I put one here. Now it's probably gonna give me, oh, it shows up, but gives me incorrect value. So it's still an object even though there's one here, which is interesting. With the following CSV dataset of wine reviews into a data frame called reviews. The file path to the CSV file is this one. This first line looks like. So the first line is the index. So it's gonna be pd.read CSV string. Oops, did I do? Okay, now it's back to normal. I'm gonna take this here. Index call equals 0. Yeah. Run the cell below to create and display a data frame called animals. I guess just run. The step below write code to save this data frame to disk as a CSV file with the name cows and goats.csv. So I don't remember exactly how to do this, but maybe just pd.read again and animals, but it has to have a value name. The pd.read CSV function is well endowed over. You can see in this data set that the CSV file has a built-in index. Pandas, though, this is the index stuff. So it doesn't have anything about saving that file. Sure. I think the way that I was doing this on the project is just typing with open, then parentheses, the file name, then I put the write method and write to another one. It's obviously not what they want me to do here. So I think I can do this on the same page next time. I have no idea how to do this. Oh, maybe I can use pd data frame. The best animals. So the data frame has to come. Hmm. because none of these methods create a file out of nowhere. The data frame creates the data frame, but it doesn't save the file anywhere. Yeah, it doesn't make sense to be data frame here because it's already a data frame. But if I write and read CSV, it's only gonna read the thing. I'm gonna get the hint. I'm not sure. Choose CSV to save data frame. Choose CSV file. So I guess it's just animals dot choose true CSV. I wasn't sure if I can use other methods that are not talked about. I've seen this choose CSV before when I was doing the project, but they haven't. I don't think they talked about it. Nice. So I think I can do them on the same page. Selecting specific values of a pandas data frame are serious to work on is an implicit step in almost any data operation you run. So one of the first things you need to learn in working with data in Python is how to go about selecting the data points relevant to you quickly and effectively. To start the exercise for this topic, please click here. Uh, I think I have to read first, maybe. Yeah, I'll read first and then maybe it's better to do in separate things so I can check separate tabs so I can check the code when I get lost. I can check the tutorial. So it's pretty much the stuff from the past one. Native accessors. Native Python objects provide good ways of indexing data. Pandas carries all of this over all of this over, which helps make it easy to start with. Consider this data frame. Python, we can access the property of an object by accessing it as an attribute. A book object, for example, might have a title property, which can access by calling book.title. Yeah. Columns in a pandas data frame work in much the same way. Hence, to access the country property of reviews, you can use reviews.country. So a column is an object, pretty much. Yeah, reviews, but yeah, reviews.country gives the whole column of countries. If you have a Python dictionary, We can access its values using the indexing this operator. We can do the same with columns in the data frame. Yeah. These are the two ways of selecting a specific series out of a data frame. Neither of them is more or less syntactically valid than the other. But the indexing operator does have the advantage that it can handle column names with reserved characters in them. If we had a country providence column, we use the country providence wouldn't work. It append the series doesn't append the series look kind of like a fancy dictionary? It pretty much is, so it's no surprise that to drill down to a single specific value, we need only use the indexing operator once more. So the indexing is gonna give the values kind of like a list. Indexing in pandas. The indexing operator and the attribute selection are nice because they work just like they do in the rest of the Python ecosystem. As a novice, this makes them easy to pick up and use. However, pandas has its own accessor operators, lock and iLock. For more advanced operations, these are the ones you're supposed to be using. Index-based selection. Pandas indexing works in one of two paradigms. The first is index-based selection, selecting data based on its numerical position in the data. iLock follows this paradigm. So iLock is gonna search for uh, kind of like if the data frame is a matrix. And I'm assuming the first argument is the thing of the row and the second one is the column. Yeah, just select the first row of data in the data frame. We may use the following reals.iLock 0. Both lock and iLock are row first, column second. So they both work with the row first and column second. This is the opposite of what we do in native Python, which is column first, row second. I never thought about it that way in Python, but intuitively it makes sense for the data frame to be row first and column second. This means that it's marginally easier to retrieve rows and marginally harder to get retrieve columns. To get a column with iLock, we can do the following. So you're catching all the rows with this parameter and the index of the column. And so on, the operator, which also comes from native Python, means everything. When combined with other selectors, however, it can be used to indicate a range of values. For example, to select a country column from just the first, second, and third row can do. So yeah, it's pretty much like Python. Or to select just the second and third entries, you do. This is selecting the number of rows it's gonna get for the first column. And I guess if I want just one item, it would be just a number for the row and the column. That will give me an item. And if either of them is zero, then it gives me the whole thing. Well, for a column, it has to be uh, the two dots operator. If the row is zero, it's not gonna give me anything, I think. If I put zero and then the number of column, because that would mean that there is no row, maybe. Yeah, yeah. It's also possible to pass a list. So the list is gonna be whatever. Well, it's kind of unclear. I am assuming that each number inside the list is the value of the index of the row that it's gonna take. Finally, it's worth knowing that negative numbers can be used in selection. This will start counting forwards from the end of the values. So it's pretty much like the way it works in Python as well. Label-based selection. The second paradigm for attribute selection is the one followed by the lock operator. Label-based selection. In this paradigm, it's the data index value, not its position, which matters. For example, to get the first entry in reviews, we would now do the following. It's the data index value, not its position, which matters. So what's the difference between that? Yeah, so it's searching for a column and row, but it's using only the first ones. And that's kind of confusing for iLock to it's gonna take me a while to become comfortable with automatically understanding which rows and columns I'm getting. I was having a lot of trouble trying to figure out how to get a specific item out of the column, out of the data frame, and not the whole column or list when I was doing stuff. Index based selection. Selecting data based on its numerical position in the data. Select the first row of data in a data frame. We may use the following. So each number is the entire thing and not the location. Well, unless, yeah. If you specify the column, it's going to be the location as well. They seem so similar. And having trouble understanding the difference between the two. I think lock picks up on the value of the index and the column on the first column, and iLock just picks up on the entire value. That's the difference. So if I put two numbers for iLock, it's gonna give me the entire thing. So let's say first row, first column. Well, no, that doesn't make sense. It still gives me just the item, I think. Get the first entry in reviews. We will now do the following. So, so the iLock is the other way around. No, this is the index stuff. I wish they showed the comparison between them. They had the same example for iLock. Maybe it is. No, it's just the first value, not the first row. Lock is conceptually simpler than lock because it ignores the data set's indices. When we use iLock, we treat the data set like a big matrix, a list of lists, one that we have to index into by position. Lock, by contrast, uses the information in the indices to do its work. Since your data set usually has meaningful indices, it's usually easier to do things using lock instead. For example, here's one operation that's much easier using lock. So it's getting all rows for these columns. Maybe. Yeah, all rows for this column. Oh, because in iLock you would need to know the indices of the columns, I think. Because you would need to know that is the first taster name is whatever column it is, and taster Twitter handle, and the lock you just select by the name if you know the name of the column. Now I get it. Why? They're very similar, pretty much, but the only difference is that you can use the names of the data frame if you know them, block, which makes it easier to sometimes, probably. Choosing between lock and iLock. When choosing or transitioning between lock and iLock, there's one gotcha worth keeping in mind, which is that the two methods use slightly different indexing schemes. iLock uses the Python standard library indexing scheme, where the first element of the range is included and the last one excluded. So 010 will select entries 09. Lock, meanwhile, indexes inclusively. 010 will select entries. Why did they make this shit so hard? It's already really hard. Then they make it even more difficult by doing this kind of stuff. I guess it's necessary somehow, but it's really annoying. Like, why not make the same way everywhere? So lock, which one is? Lock doesn't include. No, lock. iLock doesn't include and lock includes. Why the change? Remember that lock can index any standard library type, strings, for example. Oh, that's why. If we have a data frame with index values apples, potatoes, and we want to select all the alphabetical fruit choices between apples and potatoes, then it's a lot more convenient to index the after lock and potatoes. Then it is to index something like the f lock. Potato. D coming after S in the alphabet. This is particularly confusing when the data frame index is a simple numerical list. In this case, df.iloc 0 to 1000 will return 1000 entries, while it's going to return 1001 of them. To get 1000 elements using lock, you need to go one lower and ask for, yeah. So lock includes and iloc does. Otherwise, the semantics of using lock are the same as those for iloc. Um, Maybe I should type this. Lock includes, lock does. I think it's fine. I write it down here if I want to save it later. No, it's the other way around. No, iloc includes. No, iloc doesn't include. It's the other way around. Manipulating the index. Label-based selection derives its power from the labels in the index. Critically, the index we use is not immutable. We can manipulate the index in any way we see fit. The setIndex method can be used to do the job. Here's what happens when we set index to the title field. This is useful if you can come up with an index for the dataset which is better than the current one. Okay. Conditional selection. So far, we've been indexing various strides of data using structural properties of the data frame itself. To do interesting things with the data, however, we will often need to ask questions based on the conditions. For example, suppose that we are interested specifically in better than average wines produced in Italy. You can start by checking if each wine is Italian or not. Reveals that country equals Italy. This operation produces a series of true-false booleans based on the country of each record. This result can then be used inside of lock to select the relevant data. Yeah, so I did this as well in the project. It's pretty much a boolean inside of lock that is gonna determine which values it's gonna return true or false for the values of the column or the row in this case. But now I'm wondering if you have to specify here. I'm thinking about stuff that I did on the project because I'm not sure if I did it right the right way. Now that I think about it. This data frame has 2000 rows. The original had 130. That means that around 50% of wines originate from Italy. We also wanted to know, so I guess that's the thing. I'm not sure if this is searching for the whole data frame or from this it seems that it is, but from the explanation previously, since there is no column specified, then should be just the first, which it is country in this case. Yeah, I guess it starts counting after the index, so this would be the first column. Maybe I should open the thing. To review what I've done. That means that we also wanted to know which ones are better than average. Wines are reviewed on an 80 to 100 point scale. So this could mean that when mean wines that are accrued at least 90 points. We can use the ampersand and to bring the two questions together. Ampers ampersand. Not sure what this word means, but so this is looking for the true boolean things. Reveals that points is gonna be another column. So I guess it looks for the condition on the whole data frame, not just the first row. Yeah, that wouldn't make sense. But it's kind of confusing because of the way that works. So here, yeah, I use this condition here. I put this inside a variable. Then I use the this variable to filter the data frame. Filtering the data frame for columns that have a high correlation. So I guess it's right based on the example. What I was doing here is finding the correlations between the values of the numbers in the data frame that they ask you to analyze. And then use this method, which is one method of finding linear correlations between different points of the data frame. I guess it's right. I'll look at that later, I think. The way that I did it is probably correct. Suppose we buy any wine that's made in Italy or which is rated above average. For this, we use a pipe, which is the R operator. Pandas come with a few built-in conditional selectors, two of which we will highlight here. The first is icing. Icing is lets you select, I think, I'm not sure if this is written correctly. Lets you select data whose value is in a list of values. So is in. For example, here's how we can use it to select wines only from Italy or France. So it's pretty much checking if it includes reveals that country is in Italy. This checks for countries in Italy and France, the first column. It still doesn't sit well with me that it works even though you're not specifying the column, the rows. In my mind, it should only look for the first row, but the second is no, and its companion. Yeah, I used this one too. This is usually I think this is used to clean values that are clean columns that have a lot of null values, or substitute the null values for the mean of the column value. These methods let you highlight values which are not or empty and, for example, to filter out wines lacking a price tag in the dataset. Here's what we would do. And then if you use dot sum, it's gonna tell you the amount of no values that each column has. If you do it for the whole data frame. Assigning data. Going the other way, assigning data to a data frame is easy. You can assign either a constant value, so creates a column, I think. Query can assign this the value everyone to the whole column, or with an iterable of values. So this makes the inverse index. Yeah. Okay. Now it's the tough part. I think it's gonna be better to open another tab because I'm probably gonna have to go back and look at it. This set of exercises will work with the wine review dataset. And the following cells to load the data, the imports and stuff. I'm not sure how big this course is. It says 4 hours there, but I'm not sure how it actually takes to get that. So did it work? I think it did. So this is the first 5 rows with all the columns. You see there is none values here, none values here. Select the description column from reviews and assign the result to the variable desk. So reviews, description. Select the first value from the description column of reviews, assigning it to a variable first description. The first value from the description column. The first value. So I'm assuming I need to use desk, which I did there before. Dot lock or iLock. Since it's description, I think lock is better because I can pass the name. Well, but I'm already in the description. So maybe it doesn't matter. Just first. So it's not the right value. So maybe it's zero. Yeah. Because I'm already taking from the this variable here, then I think it doesn't matter. But if I wasn't taking from the variable, then we'll just write reviews.log, then zero and description as a second parameter, I think. While I wait for this one, I'm gonna go to the bathroom. It's taking a long time. Maybe it broke or something like that. Shouldn't be taking this long. I think I might finish the book before I finish the project because I think I've learned this stuff that I was supposed to learn so far from the book. It doesn't go into the implementation of, it just talks about briefly, it doesn't go into how it works behind the scenes. It just tells you to apply a method there to find a solution for the machine learning part. And I think as he was just asking to do the project so you become more familiar with the data cleaning part of machine learning, data preparation, which I think is the most important, probably, because all problems are. I think the biggest challenge on machine learning is probably figuring out the way the way that the data correlates, the right way to set up the system so that the algorithm finds the correlation between points, because data is always relative. So it saves. Not sure why. Maybe I have to run this again. No, it's reloaded. Yeah, oh, it's correct. Select the first row of data, the first records from reviews. Assign it to the variable first row. So now it's reviews. Done. Lock. I can use either of them, I think. Maybe not. Maybe I lock. Expect the first row to have type class pandas series, but had type class car frame data frame. So maybe I can't do it on reviews directly. Maybe zero, then the comma thing. Or maybe, oh, maybe I have to specify that. Maybe it's the other way around. Next person. Well, let's try like this. So let me do it the other way. Yeah. So it's all columns, first row. Let me. Oh, I don't think it's gonna let me try to do it with lock. It's just gonna keep running. But yeah. Select the first 10 values from the description column in reviews. So I can use the variable there. Task dot lock. Yeah, reviews description. First 10 values from the description column in reviews. Assigning the result to a variable for its descriptions. Format your output as appended series. Not sure what they mean by that. So lock is inclusive, I think. Maybe not. Yeah, lock includes. That's right. I'm trying to think if I would do it like this on iLog. Let's see if this is correct. Maybe, yeah, I don't need this. Expected first description should have length 10, but was, oh, yeah. I even said that is inclusive. So let's try iLog now. Yeah, same thing. Select the records with index labels 1, 2, 3, 5, and 8, assigning the result to the variable sample reveals. So records, I don't see a records here. Oh, so it's the index labels. Trying to remember if they talked about index. I think it has to be iLog. So review that's iLog. Then it's gonna be 1, 2, 3, 5, 8. Assigning the result to the variable sample reveal. And then it's gonna be all columns, I think. Let's see if this works. Reveals. Nice. Create a variable df containing the country, province, region 1 and region 2 columns of the records with the index labels 0, 1, 10, and 100. So this is gonna be lock. That should be lock because it's giving me the name. Country, province. So it's gonna be two lists. I think it doesn't have to be a list of lists, just two lists. Nice. Create a variable df containing the country and variety columns of the first 100 records. Containing the country and variety columns of the first 100 records. So it's pretty much gonna be the same thing, I think. It's gonna be from 0 to 99. I'm not sure if I have to wrap it inside a list there, the first value, but I guess we'll see. You may use lock or lock when working on the answer this question. The several of the ones that follow keep the following gotcha described in this. Nice. Create a data frame with Italian wines containing reviews of wines made in Italy. Containing reviews of wines made in Italy. So I need to use reviews, not country. Yeah, reviews. That's the filtering one, I think. Nice. Create a data frame top Oceania wines containing all reviews. It's gonna be the same one as the other one, just with a different correlation condition. Reviews don't. I think it's points with at least 95 points out of 100 for wines, Australia or New Zealand. So here has to be Australia. I forgot which one, which column. Yeah, it's points. Maybe I have to wrap this inside of parentheses. But now I'm gonna have to reload this thing again. I'll copy this just in case. I'll try to do it without doing the other cells. Then I just run all of them at the end. It still doesn't work. Australia or New Zealand? Maybe we need to put review points inside of each one. Just put it here. So it's either one or the other. Still doesn't work. Maybe if I put them on a parenthesis, is better. On a thing. On a list. It's, this is a smaller mistake. That's the issue here. Yeah. Still doesn't work. Let me check for the hint. Let me see here as well. Oh, easing. Maybe I need to use this. That's the thing. Oh, and I'm not using country. No, yes, I'm using. So I forgot about this method. Let's just check now. It's still not right. It's giving me some value at least. Let me run without this part here. So maybe they both have to be inside parentheses. Nice. Okay. Introduction. In the last tutorial, we learned how to select relevant data out of a data frame or series. Looking the right data out of our data representation is critical to getting work done, as we demonstrated in the exercises. However, the data does not always come out of memory in the format we want it in right out of the bat. Sometimes we have to do some more work ourselves to reformat it for the task at hand. This tutorial will cover different operations we can apply to our data to get the input just right. We'll use the wine magazine data for demonstration. Summary functions. Pandas provides many simple summary functions, not an official name, which restructures the data in some useful way. For example, consider the describe method. Yeah, I've used this one in the past and the info too. This method generates a high level summary of the attributes of the given column. It is type aware, meaning that its output changes based on the data type of the input. The output above only makes sense for numerical data. For string data, here's what we get. So yeah, you get float and then object. If you want to get some and if I remember correctly, is no, never mind. I think yeah, if you have both, in both objects and numbers, is gonna give you the numbers by default, and it's not gonna show the object ones. If you want to get some particular simple summary statistic about a column in a data frame or series, there is usually a helpful pandas function that makes it happen. For example, to see the mean of the points allotted, uh, how well an averagely weighted wine does, we can use the mean function. To see a list of unique values, we can use the unique function. To see to see a list of unique values and how often they occur in the data set, we can use the value counts method. Okay, so value counts is unique and how. So this might be good to find outliers in the data set, but maybe not. And categorical data makes sense, but in numerical, probably not. Well, maybe it does make sense too, because outliers would be the ones that are unique and don't happen very often. Maps. A map is a term borrowed from mathematics for a function that takes one set of values and maps them to another set of values. In data science, we often have a need for creating new representations from existing data, or for transforming data from the format it is in now to the format that we want it to be in later. Maps are what handle this work, making them extremely important for getting your work done. There are two mapping methods that you will use often. Map is the first and slightly simpler one. For example, suppose that we wanted to remean, remean the scores the wines received to zero. We can do this as follows. So get the mean, then use map lambda. Lambda I think is a way to say function. B minus review points mean. The function pass to map should expect a single value from the series, a point value in the above example, and return a transformed version of that value. Map returns a new series where all the values have been transformed by your function. So I'm not sure if I understand very well what that function is doing. Subtracting the mean of out of every value, I guess. Yeah, so the mean would be zero, and the other ones would be the deviation from the mean. Apply is the equivalent method if we want to transform a whole data frame by calling a custom method on each row. So applies for when you want to apply a function. Yeah, that is interesting. The equivalent method if we want to transform a whole data frame by calling a custom method on which row. Well, what happens with the categorical ones? If we had called reviews that apply with axis index, then instead of passing a function to transform each row, we will need to give a function to transform each column. This is the same thing. Is at the end of the day you're still oh that it's not the same thing because the function is gonna run on either each list or each column or each row at the time. Even though it's gonna go through the whole data frame the two times. Note that map and apply return new transformed series data frames respectively. They don't they don't modify the original data they're called on. If we look at the first row of reviews, you can see that it still has its original points value. So I want to go back to really understand the difference between map and apply. So map only accepts one argument, I think. The function you pass to map should expect a single value from the series, a point value. So it's only applied on a point, the series. That's still not very clear to me because the example shows that it's changing the whole value of the series, not just one. And return a transformed version of that value. Map returns a new series where all the values have been transformed by our function. Oh, so I get it. Map is just one series, so it's either one row or a column, I think, and applies for all columns and all rows when you're using it. Yeah, that's the difference. So map is for a series and applies for the whole thing. Maybe I should write this down because I'm gonna forget for sure. So dot map. I'm not sure if it can be list or column, row or column. I'm assuming it is, but I'm not sure how you say that. You specify if it's list or column. Pandas provides many common mapping operations as built-ins. For example, here's the first way of meaning our points. I think I read this before. In this code, we are performing an operation between a lot of values on the left hand side, everything in the series, and a single value on the right side, the mean value. I haven't read this before. Pandas looks at this expression and figures out that we must mean to subtract that mean value from every value in the dataset. Yeah. So it's taking all values of the points and subtracting to the mean. I remember I had a lot of trouble with substituting the no values with mean values. So I'm thinking about if there is any way that I could do better using this stuff here. And now that I think about it, I'm probably can use apply to that. Yeah. And instead of doing that, I created a list and then looped through the list. Pandas will also understand what to do if we perform these operations between series of equal length. For example, we will also understand. For example, an easy way of combining country and region information in the dataset would be to do the following. These operators are faster than map or apply because use they uses speed ups built into pandas. All of the standard Python operators and so on work in this manner. However, they are not as flexible as map or apply, which can be more advanced which can do more advanced things, like applying conditional logic, which cannot be done with addition and subtraction alone. So I think one way that I could have done that is calculate the mean and then assign it to a variable. Yeah, but I would have choose map, I think. Choose substitute and I would still need the list, I think. Yeah. Yeah. Now you are ready to get a deeper understanding of your data. Run the following cell to load your data, some utility. What is the median of the points column in the reviews data frame? I'm waiting for this. So that's just median stuff. think it's like that. Let's go back. What is the median of the points column in the reviews data frame? So what's wrong with what I did there? I don't understand. So maybe I should be median. So no, but it's mm, yeah. Okay. What's the difference between median and mean? What countries are represented in the dataset? Your answer should not include any duplicates. Yeah, this is a harder one. What was the function to see if there's duplicates? So the mean is the sum divided by the amount of numbers. No, the median is the number in the middle. So I'm gonna have, oh, it's unique. So it's just, I think, I really think I need to choose lock and that stuff, probably. How often does each country appear in the dataset? Create a series of reviews per country, mapping countries to the count of reviews of wines from that country. Hmm. So I need to use map, I think. The reviews of wines. So it should be reviews dot country dot map. But now is the part that I'm not not sure about. So maybe I should do lambda b b dot unique, something like that. Let's try to put this stuff. Maybe let's use countries. That doesn't work. It's not unique. It's the other value counts. So, but that doesn't make sense. Maybe it's just value counts. Not sure if I should use map. Yeah. Create variable centered price containing a version of the price column with the main price subtracted. So reviews price reviews. Nice. I'm an economical wine buyer. Which wine is the best bargain? Create a variable bargain wine with the title of the wine with the highest points to price ratio in the data set. With the highest points to price ratio. Now, how do I say that it's the highest? Maybe here I should use map and do a lock there, something like that. Yeah, I don't think I need to use lock or I lock because I'm not sure if they mix lessons on these exercises or if you're just supposed to use stuff from the exercise, from the tutorial. And I don't think I need to create a function on this one. This is probably wrong, but the highest. See what value counts return. These have unique values and how often they occur in the data set. So value counts is unique. No, let's see the highest. Returns a new series. I can do map and divide one by the other and get the first value, but I have to do it in one line only, I think. I don't think I should use maps or apply incident. IDX max method may be used for her. So what's this method? I hate when they do stuff like this. You put something that they didn't talked about. Maybe it's just reviews, not IDX max. Hash put type series. Hmm. Return index of first occurrence of maximum over requested access. So x is 1 maybe for column. Return series. Indexes of maxima along the specified axis. So I'm assuming the first one is the highest. So maybe I should use 0 20. For the maximum value in each column. So I'm not sure how this works still. It says it returns a series, but returns the index for the maximum value in each column. So I guess it should be the other way around. No, but here's with no arguments. Maybe this is outside. So maybe now it works. I'm just gonna see the solution on this one. Oh, I do need two lines. Oh, so this gets the largest, divides the true, then it returns the series with the largest of the whole thing, and then it uses lock to find. So I do need to do the two lines. Let's. Yeah, it's asking for the title, so that's why there's a title there with the title of the wine, the highest point. There are only so many words you can use when describing a bottle of wine. Is a wine more likely to be tropical or fruity? Fruity. Create a series descriptor counts, counting how many times each of these two words appear in the description column in the data set. Yeah, that one is this one is also difficult. How many times each of these two words appear in the description column in the data set? So the first thing that comes to mind is reveals that description, but not unique. Maybe I need to do two lines again. So the output's gonna be an array with all the unique values on the thing. I can just loop through the array, but I don't think that's what they want me to do. That's what I would do normally, I think. Or maybe the value counts thing gives the series with the see a list of unique values and how often they occur in the data set. Use the value counts method. Yeah, just value counts, I think. And then I sum the show. Oh, no, but how do I access this? Maybe I should be like this. Or the other way around. The above exception was direct because cause of the following exception. Here, fruity. If I do it like this, I don't think it's gonna work, but it's worth trying. Counting how many times each of these two words appears in the description column in the data set. It would be useful if I could see what I'm getting out of these two words. I think value counts is gonna return series. Yeah, it's just gonna return this, but I'm not sure how do I access the values there. What is states their name? I forgot how to access stuff in a series. A series is basically a column. So that should be a flock, maybe. Maybe just the way I was using lock that it's wrong. So if I imagine having a row and a column, it's probably not gonna work. I still haven't used map and applied. Maybe that's the time to use it. Hmm. I guess this works, but they don't want me to do like this. No mode index, so validate all of the indexes. And this doesn't work as well. This will fail if the label is not present in the access. Maybe I do need to create a loop. That's the only way I can think about it. Let's see if they say anything on the hint. Use a map to check each description for the string tropical. Then count up the number of times this is true. Yeah, so they want me to use a loop. Not not very used with using lambda to build functions. So I'm not sure how to do this because I would do it with accounts here equals 0, counts plus equals 1. Maybe it's return count plus equals 1. No. I think I got the point. I'm just gonna look at the solution. I could do it this in a way by building a raw function. So the issue is I'm not sure what map returns. It's gonna return a series in this case. Map returns a new series where all the values have been transformed by your function. Maybe it's just this. So yeah, I have to transform into a number. curious if I use value counts, if it's gonna work, but I don't think it will. I think I'm just gonna look at the solution. I don't understand this function pretty well. What they did here. Oh, they used dot sum. Yeah, that makes more sense. I forgot about dot sum, but and the way that I did this is also correct. So that should be the other way around. Yeah, I don't understand this function here. I guess it's just looping through every value of the description column, searching for when it's tropical. Maybe it's because it's a series, so searching for when the value of the key of the series is going to be tropical. Not very clear to me. We like to host these wine reviews on our website, but a rating system ranging from 80 to 100 points is too hard to understand. We like to translate them into simple star ratings. A score of 95 or higher counts as 3 stars. A score of at least 85 but less, and 95 is 2 stars. Any other score is 1 star. Also, the Canadian, I don't know how to say this, association bought a lot of ads on the site. So any wines from Canada should automatically get 3 stars, regardless of points. Yeah, that's questionable, but create a series, star ratings with the number of stars corresponding to each review in this data set. with the number of stars corresponding to each review in the dataset. So goes from 80 to 100. I don't think I need this. Maybe I do. No, probably not. So I'm guessing I need to use map as well for this one. So I'm assuming I need to use map or apply. Probably map because apply is for all the columns and rows. But I'm not sure how to do this without having a big function to test the three conditions. Yeah, I have no idea how to do this. The way that I would do it with a normal function is test three conditions and change depending on the condition. But it accepts a row from the data frame as inputs and returns the star rating corresponding to the row. Row from the data frame as inputs and returns the star rating corresponding to the row. Then use data frame that apply to apply the custom function to every row in the data set. So I should do that row. Um, no, I'm not sure if it's reviews that row. Row dot description maybe, but that doesn't make sense. Maybe I need to use lock. Reviews dot description dot lock. Yeah, maybe this works. Maybe I lock. The thing is, I'm not really sure about the way that apply is gonna work. Maybe we should read that. Yeah, so it is just row dot description. Maybe this is unnecessary. No, I'm not sure if they want me to do the number or a string. Maybe I should do elif. So it tests all of them. So any wines from Canada should automatically get 3 stars. Country. So row.country maybe. Oh, it's not description, it's points. I'm tripping. Reviews.apply and the function. I didn't put name to the function. Yeah, so x is equals columns. Or maybe it's just the one. No, it should be all of them. So let me try a string. It's done. Yeah, but it doesn't make sense. One star. It doesn't work. I'm just gonna look at the solution. Oh, if it's row dot country. Oh, I did this here. Well, that's what I did. Oh, return 3. That's the issue. I was making it equal. It's done. What? Row dot country. Oh, it's equal here. Of 95. Yeah, there we go. Let me save this. It seems there's two more there. I'm not sure. I'm kind of getting tired already. It's been 3 hours. I think I'll try to do one more. Maybe. Yeah, it depends how difficult it is. Yeah, there's two more. Four, five, six. No, three more, including this one. So I think I'll do one more and then I'll take a break. Maybe finish later or tomorrow. Introduction maps allow us to transform data in a data frame or series, one value at a time for an entire column. However, often we want to group our data and then do something specific to the group the data is in. As you'll learn, we do this with the group by operation. We'll also cover some additional topics, such as more complex ways to index your data frames, along with along with how to sort your data. Okay, so we also cover some additional topics, such as more complex ways to index your data frames. Group-wise analysis. One function we've been using heavily thus far is the value counts function. We can replicate what value counts does by doing the following. Group by points dot points dot count. Group by created a group of reviews which allotted the same points the same point values to the given points. Then for each of these groups, we grab the points column and counted how many times it appeared. Value counts is just a shortcut to this group by operation. So it creates group of reviews. Think I understand. Use any of the summary functions we've used before with this data. For example, to get the cheapest wine in each point value category, we can do the following. So group by points, then guess the price. So it's kind of like a filter on Excel. You can think of each group we generate as being a slice of our data frame containing only data with values that match. This data frame is accessible to us directly using the apply method, and we can then manipulate the data in any way we see fit. For example, here's one way of selecting the name of the first wine reviewed from which winery in the dataset. So it groups by winery and then applies the function which gets the value to be the first one on the title. For even more fine-grained control, you can also group by more than one column. For an example, here's how we would pick out the best wine by country and province. So you group by these two columns, then applies the function to each row of the column, which returns the maximum. Another group by method worth mentioning is egg, which lets you run a bunch of different functions on your data frame simultaneously. For example, we can generate a simple statistical summary of the dataset as follows. So you apply multiple functions at once with this method and returns a series, a data frame, not a series, uh, of country and the values of the functions applied. Effective use of group by will allow you to do lots of really powerful things with your dataset. Multi-indexes. In all of the examples we've seen thus far, we've been working with data frame or series objects with a single label index. Group by is slightly different in the fact that depending on the operation we run, it will sometimes result in what is called a multi-index. A multi-index differs from a regular index that it has multiple levels. So groups by country, province, access description, then performance length. That's true. sure if I understand this. I think what it means is that country and province are indexes in this case. Yeah, for each value of length. Depending on the operation we run. But when with it will have multi-index and when it won't. I guess it's very situational dependent, but there's probably a logic behind it. There should be a logic behind it. So multi-indices have several methods for dealing with their tired structure, which are absent for single level indices. They also require two levels of labels to retrieve a value. Dealing with multi-index output is a common gotcha for users new to pandas. The use cases for a multi-index are detailed alongside instructions on using them in the multi-index advanced selection section of the pandas documentation. However, in general, the multi-index method you will use most often is the one for converting back to a regular index, the reset index method. Converting back to the regular. Yeah. So when you have a multi-index and you want to reset again, sorting. Looking again at countries review, we can see that grouping returns data in index order, not in value order. That is to say, when outputting the result, result of group by, the order of the rows is dependent on the value of in the index, not in the data. To get data in the order wanted, to get data in the order in wanted in, we can sort it ourselves. The sort values method is handy for this. Yeah, it's basically to getting the order of the data, not the index. I don't think I'm gonna read this now. I'm probably not gonna read this ever, to be honest. Unless I need it. Then I might search for a video or something. I'm just gonna close this. Sort values default, and that's where I stop. Sort values defaults to an ascending sort, where the lowest values go first. However, most of the time we want a descending sort. Our numbers go first, so yeah, just reverses the thing. And here it specifies which value. To sort by index values, use the companion method sort index. This method has the same arguments in default order. So here we would do the same thing, length then ascending by length. sending false to reverse. Finally, know that you can sort by more than one column at a time. Countries reviewed, not sort values by country length. One column at a time. Now it's the exercises. I'm not sure how this works pretty well. Because how, which one's gonna have priority on sorting? Oh, it's maybe it sorts first the country, then within the country the length. Yeah, that makes sense. I think I'm already getting tired, so we're gonna stop here and continue some other time. It's been 3 hours already. The most common wine reviewers in the dataset. Create a series whose index is the taster Twitter handle category from the dataset and whose values count how many reviews each person wrote. So maybe reviews not group by taster. No, I think it's yeah, it's a string parenthesis. And forgot the thing. So create a series whose index is the taster Twitter handle category from the dataset, and those values count how many reviews each person wrote. I think it's the same as this one. Count. Probably not. Probably not this. But yeah, it's probably not this. It needs to give me a series, but I need to take this off. Why is this not working? I'm just gonna look at the solution no, it has to be followed by this Twitter handle. I don't understand what group by does then. I guess I'll watch your video later. Yeah, I think I'm gonna stop now and come back another time. So yeah, because I'm already tired and it's gonna be counterproductive. So see you on the next time.